Web servers play an important role in connecting people around the world through the internet. Every day, users send millions of requests for content via their web browsers, and it's web servers that answer those calls. Let's look at how this request and response routine works, and get some more details about the capabilities and functionalities of web servers. By the way, we've put all of this information in a blog post. Check the description below for a link to that. A user's website experience is built on a series of requests and responses. First, the user opens the browser and enters a URL. Let's say example.com. Every device that is connected to the internet has a unique IP address. Think of it like a phone number. The browser sends a request to the domain name system, or DNS, to look up the IP address that belongs to example.com's web server. Using DNS to translate a URL into an IP address allows your browser to know exactly where to send the request. A DNS request is processed through a hierarchy of servers. The recursive resolver receives the initial request and passes it along to the closest root name server. The root name server has information about top-level domains, or TLDs, such as .com, .net, and all of the country-based domains. So it instructs the recursive resolver to pass along the request to the appropriate TLD name server. The TLD name server stores information for second-level domain names, like example.com, and instructs the recursive resolver to pass the request along finally to the appropriate authoritative name server. The authoritative name server looks up example.com's IP address, let's say 192.0.2.0, and returns it to the recursive resolver, which finally sends the information to the browser. Thanks to DNS, the browser now knows to send the user's example.com request to 192.0.2.0, where the web server will receive it. The web server's job is to receive the request, fetch any necessary content, and then send a response back to the browser. First, the web server receives the request and interprets it. For example, is it a GET request or a POST request? It checks if the requested content is static, like HTML, or whether it requires dynamic generation, like PHP or Python. The next step is fetching or generating content. If the requested content is a static file, the server simply retrieves it. If it's dynamic content, the server processes the request using back-end languages, connects to databases if needed, generates the appropriate response, and retrieves the generated response. Once the content is ready, the server wraps it in an HTTP or a secure HTTPS response and sends a response with the requested content back to the browser. After all of these steps, which usually take a fraction of a second, the browser renders the requested content from example.com for the user. A web server is a collection of specialized software installed on a physical server. This could be a machine similar to your computer at home. The software listens for incoming requests from browsers. These requests are usually made via the HTTP or HTTPS protocols and could involve fetching static files like HTML, CSS, and JavaScript, or processing dynamic data. Let's look more closely at these ideas. A web server essentially consists of three things: a physical computer or virtual machine, an operating system, and web server software. The physical computer or virtual machine acts as the foundation of the web server, providing computing resources like CPU, RAM, and storage, and network connectivity to support web hosting. The resources can be dedicated to a single user or shared with several users. The underlying operating system, or OS, manages hardware resources and provides a platform for other components in the system. These components, plus the OS itself, are also called a stack. Common choices for OS include Linux and Windows Server. Linux is the most popular, well known for its stability and flexibility in server environments. The majority of web servers use some variety of Linux, like CentOS or Ubuntu. The web server software handles the incoming HTTP and HTTPS requests. In response, it serves static content, or it forwards dynamic requests to an application server. Common web server software includes Apache HTTP Server, Nginx, and LiteSpeed Web Server. We'll talk more about these later. Let's look at different types of content that may be requested from a web server. When the web server receives a request for static content, it directly delivers pre-existing files to the browser without any modifications. It's fast because the server only has to retrieve and serve the file. Popular types of static content include HTML, CSS, and images. Dynamic content requires additional server-side processing time before the response can be sent to the browser. In a nutshell, first, the web server runs an application server script. This could be in PHP, Python, or some other language. The script may talk to a database to get specific information, such as user details or search results, depending on the request. The server generates a custom HTML page tailored to the user's request, and finally, the server sends the generated page back as static HTML to be displayed in the user's browser. This is the basic behavior of a web server: to receive a request, process it, and respond with the requested content. But there are other features that a web server supports, including security and performance enhancements. Web servers can support a number of security features, but the two most popular are Web Application Firewall, or WAF, and encryption via Secure Socket Layers and Transport Layer Security, or SSL and TLS respectively. These important features are not built into web servers per se, but all good servers support them. A WAF, usually in conjunction with a server's security module, monitors incoming traffic, inspects each request, and uses a set of rules to block anything suspicious. This helps prevent hacking attempts and traffic overload attacks like distributed denial of service or DDoS attacks. SSL and TLS encrypt the data that is exchanged between your browser and the web server, keeping sensitive information like password and payment details safe from hackers. When you see HTTPS in the address bar, you know that the server is using SSL or TLS to create a secure connection, scrambling data so that only the right people can read it. SSL and TLS protect personal information from being intercepted, ensure data isn't altered during transmission, and confirm that the website is genuine. SSL support is built into the web server, but it uses certificates that are generated externally via a certificate authority, or CA, like Let's Encrypt. In addition to security, web servers provide important performance features, such as compression and caching. Web servers use gzip, Brotli, and other technologies to compress the size of files sent from the server, making them faster to download. The browser decompresses the files upon receipt. This saves bandwidth and decreases page load times, a boon for users with slower connections. A cache is used to store static copies of frequently requested dynamic content. Web servers that make use of caching serve the static copies rather than regenerate the dynamic content each time it's needed. This significantly reduces server workload, saves resources, improves load times, and provides a better user experience. Now let's take a look at a few popular Linux-based web servers and see what sets them apart from each other. Apache HTTP Server was launched in 1995 and is one of the earliest web servers. Still widely used today, Apache was developed as an open source project and gained popularity for its flexibility and ability to run on multiple platforms, such as Linux and Windows. Apache revolutionized web hosting by making it accessible and customizable. Its modular design attracted users who were able to adapt the server for a wide range of web-based applications. Even today, Apache powers millions of websites worldwide. Nginx, on the other hand, was released in 2004 and was designed to solve the problem of handling 10,000 concurrent connections efficiently. This is also known as the C10K problem. Nginx's lightweight, event-driven architecture made it an attractive choice for high-traffic websites. Known for its high performance, scalability, and low resource usage, Nginx excels at serving static content and handling a large number of simultaneous connections. It's often used as a reverse proxy and load balancer in front of Apache servers, as it is better at efficiently handling heavy traffic than Apache tends to be. Lastly, LiteSpeed Web Server was launched in 2003. It was designed for speed and efficiency, developed to address the performance limitations of traditional web servers like Apache. LiteSpeed Web Server offers seamless Apache compatibility and significantly better performance, especially for dynamic content and SSL handling. Its compatibility with Apache configurations allows for easy migration, making it attractive for users seeking better performance without reconfiguring their entire setup. LiteSpeed is known for its speed, resource efficiency, and robust security features. It excels in server-side caching and is a go-to solution for web hosts prioritizing speed, security, and scalability. We hope this overview has given you a sense of what web servers do and the vital role they play in the functioning of the internet. Thanks for watching, liking, sharing, and subscribing.